Welcome to the deep dive. Today, we're jumping straight into a topic that is, well, it's fundamentally changing how we all interact with technology.
It really is.
We're not just talking about using AI anymore, we're talking
Yeah.
about programming it and doing it with nothing more than, plain language.
That's exactly right. Our listener is putting together a serious masterclass on prompt engineering, and our mission today is to really pull out the core curriculum,
The absolute essentials.
the foundational insights that take you from just, asking a vague question to what the source material calls sophisticated natural language programming.
And the main idea here, it's kind of staggering when you think about it. Prompt engineering is basically the first time in history where language is the code. We're going way beyond simple chats and learning how to navigate what the experts are calling a high-dimensional probability space.
That is a beautifully precise phrase.
Yeah.
Because that's what it is. Think of prompt engineering as this rigorous art and science of control.
Control over what exactly?
The AI has an almost infinite range of things it could say, and your prompt is the carefully designed input that just narrows that colossal space down to one specific high-quality result. It's all about precision.
Okay, let's unpack this, because before we can even start to engineer an output, we have to get a handle on the machine itself.
Yeah.
So what is actually happening under the hood? I mean, how do these models think if they don't actually understand meaning?
And that is the absolute key. To get good at this, you have to accept one core reality. The AI doesn't understand meaning or context like a person does. It just calculates likelihood.
Likelihood.
It's a purely statistical engine. It looks at the words you gave it and just predicts the next most probable sequence of characters, or more accurately, tokens.
Right, tokens. That's the real currency of AI, isn't it?
Precisely. It doesn't see words. It sees these little chunks of characters called tokens. The rule of thumb we use is that about 1,000 tokens is, maybe 750 words.
And understanding that explains some of the weird quirks you see.
It does. It explains why some complex words might take more processing power. They get broken up into multiple tokens inside the model.
Which brings us to this fascinating little tip from the professor's notes. If you find the AI is struggling with a word, like a technical term or even just spelling, you can sometimes fix it by hyphenating it, like STRAWBERY.
Yes, that's a perfect example. You're not talking to a linguistic layer, you're communicating with the statistical layer. By hyphenating, you force it to tokenize the individual letters, which completely shifts its math.
So you're basically interacting with, like, an autocomplete on steroids.
That's all it is. And the entire game of prompt engineering is just shifting those statistical probabilities to get what you want.
And when that prediction goes wrong, when it's super confident about something that's just not true, that's when we get the infamous hallucination.
A hallucination is just that, a prediction made with very high confidence that happens to be factually wrong. It happens because the AI is optimized for plausibility over accuracy.
It wants to sound right more than it wants to be right.
Exactly. If your prompt is too vague, it will follow the most probable path of tokens that sounds correct, even if it has to invent facts to do it.
So this all comes back to the idea of the prompt as a kind of lens. The AI is this giant universe of information, and the prompt has to be sharp enough to focus all that light onto one tiny, useful point.
That focus is everything. It's the difference between a beginner and a pro. Beginners are polite, they use conversational fluff. An engineer treats the AI like a machine that needs rigorous, technical inputs.
Which is why the hierarchy is so important. You can't confuse a command, an instruction, and a prompt.
Absolutely not. A command is simple. Summarize this. An instruction adds rules. Summarize this in 3 bullet points with a professional tone.
But the prompt, that's the whole thing.
The prompt is the entire environment, the context, the constraints, the examples, the data. It's the self-contained universe you build for the AI to work inside.
Okay, so what's the blueprint? What's the chemical formula, the 5 essential ingredients for a high-performance prompt?
Right. There are 5 key components. First is role, or persona priming. You have to assign the model a specific expert identity.
And not just act as an expert.
Never. That's a waste of tokens.
Yeah.
Be specific. Act as a skeptical academic peer reviewer specializing in 18th century French literature. That tells the AI exactly which vocabulary and knowledge subset to pull from.
Okay, so that's role. What's number 2?
Number 2 is the task. It has to be a clear, action-oriented verb. Analyze, synthesize, draft, critique. It anchors the AI's intent.
And then context.
Third is context, the why and the who for. This provides what we call latent variables, the unspoken things that influence the outcome.
Like, the audience is a CEO with 10 minutes to read this, and the goal is to get project approval.
Precisely. Without that, the output is just generic. With it, it becomes a useful tool.
Okay, number 4 is constraints. This is where you set the boundaries. But I do worry if I add too many rules, don't I risk limiting its creativity? Where's the line?
That is a brilliant question. And you're using constraints to shape the output, not just limit it. Think of them as positive and negative. A positive one might be inject one moment of self-deprecating humor.
Okay.
But the negative constraints are often more powerful. Do not use the word disruptive or avoid all business jargon. You're forcing it away from cliché, low-value answers.
That makes sense. You're focusing the creativity by getting rid of the noise. And finally, the output format.
Yes. Specifying JSON or a markdown table isn't just for looks. It makes the output immediately machine-readable. It makes it usable for the next step in your workflow.
So let's make this real. We've all done the lazy prompt, give me ideas for a business, and you get garbage.
Total garbage. Now let's engineer it. The persona is a venture capitalist in green tech. The context is 2024 market trends. The constraints are that it has to use AI and reduce suburban carbon footprints. And the format must be a table comparing investment, return, and novelty.
The lazy prompt gives you an idea. The engineered prompt gives you a due diligence report.
That's the transformation.
Okay, here's where it gets really interesting. We have the backbone. Now we need to add the muscle, the techniques that force the AI to, well, to think better than it normally would.
We're moving to few-shot prompting.
Which is basically learning by example.
Exactly. It's in-context learning. Instead of writing a huge paragraph describing the style you want, you just show it 1 to 5 examples of the input right hour output pattern you need.
So if I wanted it to summarize articles in the style of a 1940s news bulletin, I just showed 2 examples and it would just get it.
It would just get it. It activates a pattern recognition mode. You're telling it, forget your general training. For this conversation, this is the style guide. The quality of your examples is way more important than the quantity.
Then we have chain of thought prompting, or COT. This is the one that forces the AI to show its work, and it leads to these huge accuracy gains. But why? Why does just adding let's think step by step work so well?
Because it forces the AI to generate intermediate steps as tokens. It uses them as a kind of working memory. Those extra tokens, the little logic steps, they shift the probability path away from the easy surface-level wrong answer.
Like their famous bat and ball riddle. A bat and a ball cost $1.10. The bat is $1 more than the ball.
And almost everyone, humans and AIs, jumps to 10 cents. It's the most probable, intuitive answer.
But it's wrong.
It's wrong. But with Qt, the model is forced to generate the tokens for the algebra. Let x or ball cost. So x plus 1.0000. And those tokens guide it down the right statistical path to the correct answer, which is 5 cents.
Okay, but you can't rely on a user typing, let's think step by step every time, especially in an application. And that's where the system prompt comes in.
The system prompt is the hidden constitutional law of the chat. It defines the AI's core identity and rules that are very hard for a user to override.
So you put something in there like, you are a medical assistant, under no circumstances give a definitive diagnosis.
Exactly. And that rule, that core identity, persists through the entire conversation, providing a crucial safety layer.
So putting this all together, what does this mean for a professional who needs actual rigor? A researcher, a data analyst, where the stakes are way higher than just a creative poem.
It means using the right tool for the job. You need text models for creative stuff, but you need code models for logic and syntax. And you need multimodal models if you're processing images or audio.
Like the classic example of, look at this photo of my fridge and give me a recipe.
Right. But speaking of research, we have to talk about the professor's warning. AI is a fantastic liar when it comes to citations. It prioritizes what looks plausible.
A hallucinated citation can completely destroy credibility. It's a huge risk.
And the professional safety strategy is the source-first constraint. Technically, it's called ARG.
Let's define ARG quickly. It's a big one.
ARGI is Retrieval Augmented Generation. In simple terms, you don't let the AI pull facts from its huge, messy training data. You force it to first retrieve information from a small, verified set of documents you provide.
Like your company's internal knowledge base.
Exactly. And then it can only use that verified text to build its answer. The prompt strategy becomes provide the source and ask the AI to extract and format the references with one critical constraint.
Which is?
If a claim does not have a clear source in the text I've given you, you must flag it as UN verified. It builds an accountability.
Okay, now what about data analysis? We know LLMs are probabilistic, not deterministic. We can't trust them with complex math.
No, you can't. This is where prompt chaining is a non-negotiable. You break the task into steps. Prompt 1, clean the data. Prompt 2, structure the data into a table. Prompt 3, analyze the table.
And for that final, crucial calculation, the professor's lab note gives us the fix. You make it use a better tool.
Yes. For the final numbers, you add the instruction. Write and run a Python script to calculate these values rather than doing the math yourself.
That's brilliant. You're using the language model to write reliable code and then letting the deterministic Python interpreter do the actual math.
It's engineering. You're leveraging the strengths of both systems.
So as we wrap this up, it's really clear. Prompt engineering moves you from being a simple user to being a prompt architect. You're translating specific human intent into the statistical language that the machine needs.
And what's really fascinating here is that the future of this work is all about building workflows. You're treating the output of one AI step as just the raw material for the next, more specialized step. That's the heart of prompt chaining.
But there's a huge danger that comes with that automation, the error cascade.
Yeah.
If that very first step in your chain produces one tiny hallucination, say, it gets a date wrong, every single step that follows will build logically on top of that initial lie.
And your final output looks coherent, confident, and is completely, utterly wrong. That's the highest stakes risk in all of this.
So the challenge we have to leave you with, the learner, is to build in a defense against that. You have to insert a mandatory verification step into your automated workflows.
You have to. You force the AI to check its own work.
Make the required question. Does the following summary accurately represent the source text from prompt 1? Answer only yes or no. If you answer no, explain the discrepancy.
That simple constraint forces self-correction. It builds rigor into the system and protects you from those cascading errors.
Thank you for joining us for this deep dive into the language that really is powering the future.